Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from Panasas. We have Geoff Noer. Geoff is the Senior Director of Product Marketing at Panasas. So, Geoff, welcome to the show.
Thanks, Rich.
Hey, I appreciate you coming on, and I brought your slides up here, so why don't we start with that?
Okay, very good. Well, I'm very happy to be here and have a chance to talk about Scale-Out NAS and how Panassus fits into the equation. So I wanted to first start out with a little bit of just general context and definitions so that everybody knows what I'm talking about and the context there. So of course, NAS being network attached storage, but I'll be focused specifically on unstructured data, so file-based protocols, not iSCSI serving via NAS, and focusing on network protocols like Pnfs and the emerging Pnfs, of course, for adding parallelism, CIFS for Windows clients, and then, of course, Panassus DirectFlow, which has been really the most established parallel protocol out there as a precursor to Pnfs. When I talk about legacy NAS, I'm really referring to the start of the NAS appliance, a concept where you had basically a single or a clustered filer head, where that was responsible for serving all of the data behind it. And in that legacy mode, if you wanted more performance, you needed a faster filer, or you needed to go to multiple ones, and with a lot of management overhead and problems because you end up with lots of pools of storage. That problem is fairly well acknowledged and understood for many years, so I'm not going to dwell on the historical background, except in the context of explaining scale-out NAS. And as you'll see in a future slide, it really ends up being more of a continuum from the legacy to a full scale-out model, rather than being a light switch that you flick and suddenly you're in a scale-out world. So scale-out NAS is much more about the parallel access to data, serving large clusters typically, and many simultaneous clients. And so the focus is usually scaling a combination of capacity and performance. And the best ones are actually served in the back by a parallel file system, which really supports that concurrent reading and writing. And one of the key characteristics is, of course, that the data is striped across multiple storage nodes, allowing you to add more nodes to your storage to add additional performance and often capacity as well. And then the management part of the scale-out NAS has to do with global namespace or single namespace, where you only have one mount point going to all of your storage, and so as you scale the system, you still have one system not only to manage but also from a user's perspective. So moving to the next slide, the reason for scale-out NAS really has to do with mirroring in storage what the compute industry has done over the last decade. And high-performance computing has definitely been one of the big leaders here, but it's much broader than HPC. You used to have many more monolithic scale-up compute environments, and many to most of those have been replaced over the last 10 years with large Linux clusters primarily, although we also see the emergence of Windows for some workloads as well in HPC and other markets. And so if you have many hosts all needing to talk to storage at once, having all of those bottlenecked through a single NAS filer, it becomes a big performance bottleneck. And so scale-out NAS is the storage industry's response, with a lot more inherent parallelism. There's part of the reason for the need is also just the overall growth in unstructured data. For example, IDC has identified that just the amount of digital data is more than doubling every 2 years, and the number of files in that space is growing even faster than that. And so within HPC, you have a wide variety of workloads that are driving those sorts of data volumes. Everything from next-generation sequencing in the biopharma space to oil and gas exploration in the energy sector, a whole variety of different government and university workloads, high-energy physics, fluid dynamics and simulations in the manufacturing space. So it's the full breadth of commercial and public sector HPC. so one of so you have this need for scale-out NAS, and then the question becomes, how does the storage industry fulfill that requirement? So you have some companies that have been established before and selling the legacy NAS devices, and all of those companies have been working to enhance their products and try to make them more scale-out NAS-like. And then you have other companies like Panasas that were actually founded around this transition and around this emergence of scale-out NAS. And so Panasas started with a completely clean slate, which was a big advantage in terms of getting to a highly scalable solution that delivers the full amount of performance that's possible. Because you have a lot of progress along the lines towards scale-out NAS, with many vendors starting from a legacy perspective, you do have a continuum rather than a simple either you're a legacy or a scale-out NAS architecture. So on the next slide, looking at this continuum, really the parallel file system is what really defines whether the architecture is going to be capable of truly being a scale-out platform. And parallel access protocols are equally important. The reason that there are relatively few of these solutions out there has to do with the difficulty. And while I'm not commenting on whether this characterization is completely correct for Panasas, I think it is illuminating. DataDirect was recently asked in an analyst interview why they didn't have their own file system, and made a comment to the effect that while successful file systems take 10 years and 150 million in engineering resources to develop, and so that's a very difficult thing to just want and then suddenly have. And so you have companies like Panasas and there are others, Isilon included, that have built parallel file systems from the ground up to be the basis of their storage products. But many others have had to try to build that into their systems. So if you look at the continuum at the bottom of this slide, really what's interesting is you start out with sort of a pure legacy NAS product where you have a redundant filer head, fairly limited scaling. Every filer is managed separately. You're using legacy access protocols like Pnfs, and you end up with multiple mount points. Well, so many of the legacy vendors like NetApp and BlueArc have been enhancing their products to move them up the chain towards scale-out NAS, many of which now offer some sort of limited clustering, maybe up to 8 or 10 nodes, moderate scalability, certainly much better than they had before, most likely unified management so that they can manage the whole storage cluster together, but still within a legacy access protocol environment. But they probably have a global namespace, although not one truly backed by a parallel file system. So the next major step is when you replace the more monolithic file system with a true parallel file system. Then your files start to be spread evenly across all of the devices. There's very good load balancing, and actually single files can actually be spread across the entire system as well, so that you can actually scale the performance of individual files up as well. Much better scalability. You still have the unified management global namespace. And then the final major enhancement comes when you also couple the parallel file system with a parallel access method like Pnfs or Panasas DirectFlow. So while you have companies like NetApp and BlueArc that are sort of in the middle now, and then maybe Isilon is maybe one step further along because they are parallel file system based. Those companies are still today based on Pnfs and CIFS and other legacy protocols that don't provide the full parallelism. So Panasas DirectFlow, as you'll find out a little bit later, and then Pnfs, the industry-wide protocol that DirectFlow helped shape, are really helping bring the full advantage of scale-out NAS to the market. So on the next slide, when I look at what are the real values of scale-out NAS? Performance is certainly a very significant part. If you don't have the performance to back up the architecture, then you really have an archival solution. But there are a lot of choices in terms of what do you want to optimize for. Aggregate throughput, is it small file, large file, metadata heavy? Those sorts of questions can help select vendors. A lot of what scale-out NAS is about, though, is large file aggregate throughput for a lot of these highly parallel jobs. And in that context, Panasas is a very strong choice in the field, especially because of the parallel protocol access. Manageability, beyond having a global namespace, the ease of scaling. Is there investment protection when you add new models? Can you just integrate them into the existing system? And then all of the RAS side of things. What special things does the system do to maximize reliability? Single points of failure. How well integrated is the whole system? How easy is it to service? All of those factors become really critical for scale-out NAS, especially because the larger the system, the more people are relying on it, and the more important the data is. So reliability becomes an especially important factor for scale-out NAS. So on the next slide, this is a sort of a very high-level comparison showing the real difference in the amount of parallelism. In the legacy environment, you have the compute clients, typically speaking something like Pnfs, through a file server, which may or may not, either it's doing software RAID, but the RAID is being done within the file server, or else it's as it's pictured here with a hardware RAID controller or multiple hardware RAID controllers. And the RAID controllers, and especially the file servers, end up being big performance bottlenecks because everything has to go through that head to get to the storage. The clustering model only helps a little bit because now you have a few file servers, but you still end up being congested, and in many cases, single directories end up getting put on one appliance, and then if you're that application talking to that directory, you end up being bottlenecked. In the Panasas case, what we've done is we've removed the metadata or the information about where data lives, and we've put those on an out-of-band type of device that called director blades. We have a fully bladed architecture. And what that means is that compute clients simply have to ask the director once where they can read and write for a particular file, and then all of the subsequent bandwidth happens in parallel directly to the storage blades where the storage is actually held. So even just in a single shelf, we have 11 blades, so 11 separate parallel processes that can be taking place there. And when you scale that up to 10 shelves, you now have 110 nodes essentially in the storage system, and we can scale that all the way up to 100 shelves or 1,100 nodes. And so that makes it very easy to handle thousands and thousands of concurrent clients, and truly, along with more than 150 gigabytes per second of throughput. And that's all possible because of the scale-out NAS architecture. And we actually use objects instead of blocks, which gives us a lot of the advantages of raw block I/O with at the same time having a much better understanding of the file level of the file system and being able to make good choices. And because of the architecture, we're actually delivering close to the full drive performance to clients. So for every high capacity SATA drive, we're actually delivering 80 megabytes per second of throughput per drive to the client. And that's a factor of about 3x what other vendors are able to provide. So I'll now speed up a little bit on some of these slides, but I did want to give you a little bit of a flavor of what the Panasas Active Store product looks like, which is our scale-out NAS system. So really, we've really combined the three main aspects of scale-out NAS in terms of really truly leading performance, not constrained by in-band filer heads or hardware RAID controllers. Very easy to use and manage, up into under 10 minutes to set up or grow capacity, and fully integrated. So unlike a parallel file system that's just a standalone file system like Lustre or IBM GPFS, those file systems certainly have good things going for them, but they are standalone file systems and software only. So one of the biggest challenges is simply a lack of integration between the hardware and the software, and that especially manifests itself in reliability and availability, and is why Panasas has had a particularly strong presence in the commercial HPC sectors, where the data is valuable. They don't have a large software team necessarily that's available to maintain the file system and to keep the system running. They expect a much more of a commercial grade experience. And so the architecture on the next slide, we really have these two types of blades. You add more director blades for more metadata performance. You add more storage blades for storage performance. And the whole concept is simply that we really maintain a very good balance between networking, storage, and CPU throughout the entire architecture. So you really scale the performance and capacity linearly as you grow the system. And the base unit is a single shelf, 60 terabytes and a 4U. And you get about a gigabyte and a half per second of throughput from only those 20 drives. On the next slide, the architecture is simply based with our own parallel file system called Pnfs, which is also the storage operating system that our appliances run. And then you have either ActiveStore 11 or 12, depending on the degree of performance that you need. And then you have your choice of protocols. We do support industry standard Pnfs and CIFS, but then for truly parallel access, we have direct flow, which over the last 7 years we've been working with the IETF and other standards committees to get built into open standards. So Pnfs, part of NFS 4.1, is the first version of NFS that actually includes what amounts to be a version of the Panasas direct flow protocol. And we're very excited about that direction of taking a lot of innovation out of from the protocol side and taking it from a proprietary Panasas only invention to something that's being used globally by multiple vendors and multiple devices. So the way that direct flow works on the next slide is that you basically, similar to the hardware architecture, you basically have your director blades doing the metadata, and so they answer questions like where your files are, and then all of the reads and writes happens through direct flow straight to the storage blades. You get that single namespace, and so that's also how we deliver the 80 megabytes per second per drive. Is basically each blade has 2 drives doing 160 megabytes per second, and you scale that up by adding more blades. For those environments that can't support direct flow, you can still use NFS and CIFS. It'll just be slower, and you can still scale it up, but you won't get as much of the benefit as if you had a fully parallel protocol. And we do actually scale performance of single files. If you spread, for example, a 1 terabyte file across 100 shelves, you will actually get 100 shelves worth of throughput to that single file. So we actually, with the object-based architecture, the striping, the rebalancing that's automatically done in the background, read-aheads and write-behinds on the storage, we can make use of all of the cache that we have in the system, as well as the CPU and the disk, to really optimize the performance. On the next slide, you can see the comparison for the 3 products that we're currently shipping. The 2 main ones, ActiveStore 11 and 12. The 12 is the performance leader, 1,600 megabytes per second writes, 1,500 megabytes per second reads. ActiveStore 11 is about 20% less expensive and about 2/3 at the performance level. But again, in a large cluster, at 1150 megabytes per second, if you have 10 of those shelves in one system, you're still over 10 gigabytes per second. So both the 11 and 12 are definitely fully characterized as high-performance devices. And the file creates per second, this is only for one director blade. And so as you scale this up, you can actually scale up to hundreds of thousands of file creates per second. So the metadata performance is just as scalable as the throughput. Ease of use on the next slide has been a big focus point for Panasas since day one. We've had the ESG labs has validated that it took them less than 10 minutes to set up to get to the first mount point in reading and writing data, and so we really make it very easy to get all of that performance, and then once it's set up, to continue to be easy to use and manage. On the next slide, we have of course a full-featured CLI, but we also have a nice proactive PanActive manager that gives you all sorts of event notifications, monitoring. You can set up private clouds fairly easily if you need to monitor the capacity utilization of individual volumes or blade sets. And then finally, on the next slide, reliability, availability between the object RAID that we do, where we mirror small files and stripe large files. We have both horizontal and vertical parity, so we have dual parity for extra degrees of reliability. That actually also helps mask individual media errors. And then we have very rapid RAID reconstruction. Because we don't have the hardware RAID controller, we can have all of the director blades in the system all working together to reconstruct data in case of a drive failure. So that means that basically the larger the system with Panasas, the faster your RAID can be rebuilt and to get you back to a point of being protected again. And then all of the functions inside, like have support failover and failback. So it's a very robust environment, both on the hardware and on the software side. So taking this discussion back on the final slide, there are quite a wide variety of vendors who are working on scale-out NAS. That's really not something that is a niche goal at this point. This is really where the whole industry is moving for NAS. So it's more of a question of from what perspective does each vendor take to this direction. So for Panasas, that's been HPC. We define that as being both the public and the commercial sectors. And we may eventually be something technology that the enterprise sector also looks at. But today we're really primarily focused on HPC. And that's because of our large focus on performance. But equally important, I think, is the ease of manageability and reliability, because that's really what makes the Panasas solution stand out, especially from some of the software-only file system choices out there. So we would encourage customers to consider, especially not settling for less than a scale-out NAS system with a parallel access protocol and a parallel file system, especially with an HPC. If without those two factors, you're really not going to get maximum performance, and maximum performance doesn't have to be any more expensive or doesn't come with really any other strings. You really get all of the benefits of a scale-out NAS system, but you also really get to realize the full capability of all of the drives that you've purchased and deployed. So Pnfs will certainly help bring that out to additional choices, but the Panasas system is a very strong system that's widely recognized within HPC. So the focus on parallel performance, ease of use, and reliability and availability. If you have any questions, please visit the Panasas.com website. There's plenty of information there, and you can contact us through the website as well. And we would love to hear from you and answer any questions that you have. So with that, I don't know, Rich, you've been patiently listening. Do you have any questions for me?
I've been taking notes furiously here. So back on slide 6, Jeff, if you could bring that up. You mentioned that you had a 3x bandwidth advantage over competition. Is that a function of your architecture or the fact that you have your own hardware, software, and a turnkey solution?
Well, those are pretty tightly linked. So it is definitely it is the particular hardware architecture and the software architecture that we've chosen, right, and how we've married those together. If I would say that a lot of storage systems they may not be archival storage, but they're set up where they have a lot more hard drive resources than they have networking or the CPU capable of actually delivering the performance of the drives. Mm-hmm. So if you have a more limited amount of CPU and networking, those are going to end up being the choke points for getting the performance of the drives out to the clients. So what we've been with our bladed architecture, having that perfect balance of CPU, cache memory, and drives and networking, everything's very, very balanced, and that gets us all of the performance out.
So as you let's say you're expanding your storage, right? And how do you choose the balance between the director blades and the storage blades? Does it depend on your particular application mix, on how much metadata there is, or is there a formula? How does that work?
Well, so there is a basic formula, which is, generally speaking, in a single shelf, you'll have one director blade and 10 storage blades, and that tends to be the ratio that works for the vast majority of people. So as you scale up, for example, to 10 shelves of our storage, you'll end up with 10 director blades. You're correct that in a very metadata-heavy environment, we sell configurations that have a larger ratio of directors, and similarly, if a workload is particularly not metadata heavy, we can even have some shelves with one director blade and then some shelves with none at all. So we can vary the director blade mix, but generally speaking, one per shelf is the right ratio.
So when Pnfs comes out and it's available, right, as an open source thing, and everybody's that's interested in this would start serving that market, how is Panasas going to stand out at that point?
So you can always look at something like an industry standardization as either a competitive threat or an opportunity, and I guess usually they're both, right? But certainly Panasas sees this as a very big opportunity, because it takes something that we've been doing literally for 10 years, and we've had direct flow based product shipping since 2003 and under development since when Panasas was started in 2000. And so today, even within HPC, if you look at what is the number one protocol that's used for file systems, it's actually Pnfs. Yeah. So there are many workloads that don't require the extreme performance that Panasas is known for, and the emergence of Pnfs actually opens up a lot of markets for users that maybe weren't comfortable with putting a proprietary protocol like direct flow, which is it's a very easy kernel loadable module that we distribute with an RPM, and it's very easy to support with virtually any flavor of Linux. But nevertheless, there's some customers that want to use a stock Linux distribution and may not want to use direct flow. Pnfs then becomes a very appealing way of jettisoning the performance issues that accompany NFS and going to a parallel protocol. Now, Pnfs actually, there are three backends to Pnfs. There's actually an object file and a block backend. There are layout drivers that determine the way that the Linux Pnfs client speaks with storage, and that combined with the backend storage architecture in a given vendor's storage system that's going to really determine whether users see the performance out of Pnfs or not. So we have an object-based architecture. We're going to be using the object backend for Pnfs, and by using the object backend, for example, RAID is entirely computed in the cluster clients instead of in a filer head. That allows the parity computation to scale as you grow the system. It also means that we can detect network data corruption. So if there's a bad switch or some bad element between the client and the storage, because the parity was computed in the client, we know at the storage system level if something went haywire between the client and the storage. Whereas in other approaches, that when the parity is done in the storage, if there was a corruption that happened across the network, parity is just happily computed on the corrupt data. So there are a number of reliability advantages for doing it there, but it also allows us to fully scale up the performance. And what we expect is that many of our competitors will be using the file backend for Pnfs, and that will probably still yield them some good performance advantage over where they are today. But we believe that between the parallel file system architecture that Panasas has on the hardware and software side and the back end, coupled with the way that we're going to be using the object layout drivers for Pnfs, that's going to be a winning combination. A bit of a long answer, but hopefully that made sense.
Thank you. That was helpful. So, Jeff, we have SC11 coming up. Do you guys have some plans for the booth that you can tell us about?
SC11's, as always, going to be a great show for us. We'll have a good presence there, and we'd love to have people come by and visit us. We'll be showing off our Active Store 11 and 12 in the booth, and it's actually booth number 1506. Not that anybody will remember that, or you can look us up in the show magazine. We'll also be showing off some demos of applications, high performance computing applications running against our storage. So I'll keep that a secret, but come by and check us out.
Well, terrific. Well, Geoff Noer, Senior Director of Product Marketing at Panasas, I want to thank you once again for coming on the show today.
Well, thank you for hosting.
All right. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.